IGCSE Computer Science, Syllabus Statement 1.3.5D, describe the principles of operation of optical offline storage systems. So, an optical storage, optical storage is storage of data on an optically readable medium. So we're going to look at, for these devices, we're going to look at CDs, DVDs, DVD RAMs, and Blu-ray discs. So we'll move on to solid state and magnetic storage devices, and then that's it for no, not quite. We still have to look at file sizes again. But anyway, let's go ahead and get started. So CDs and DVDs. Compact discs and digital versatile discs are examples of optical storage devices. Both CDs and DVDs use a thin layer, or layers as you're about to find out, of metal and light-sensitive organic dye to store data. Both of them also use a single spiral track, which runs from the center to the edge of the disc. It's kind of like this. You have a spiral, yeah. On the track, data is stored as pits and bumps. A red laser is used to read and write data. Both CDs and DVDs can be designated an R for write once, or RW, read and write multiple times. So a DVD, however, differs slightly from a CD. A DVD can have two layers, which increases its storage capacity. The two layers are joined together with a transparent polycarbonate spacer and a thin reflector. But single-layer DVDs still have a larger storage capacity than CDs because the pit size and track width are smaller. Also, DVD layers have shorter wavelengths. The shorter the laser wavelength, the greater the storage capacity. We actually don't really see CDs and DVDs that much anymore. Like, I mean, I still have Blu-ray discs, but that's about it. Like, I never actually have seen a DVD for quite a while. But anyway, let's carry on. We'll talk more about that later. So here's how DVDs kind of look, if you were wondering. So we have a laser beam that reads this part here, and a laser beam that reads this part here. So it's semi-transparent metal reflector, which means that it's semi-transparent, which basically means that a laser can pass through it. How this works is the laser sort of changes itself to, like, sort of focuses in order to read the second layer. So in order to pass through this semi-transparent layer to read this layer here. And that's pretty much how it works. Now, there is a disadvantage to this, which we will look at. So then there's DVD RAM, and DVD RAM is quite different. Everything's different around here. It uses a number of concentric tracks instead of a single spiral track, and this allows simultaneous read and write operations as well as faster data access. They also have a greater longevity, is that how you pronounce it? Longevity, I think it's longevity. It's usually over 30 years, and this makes them ideal for archiving data. Blu-ray discs are different to the others. They use a blue laser to carry out read and write operations, and the wavelength of blue light is shorter than red light, and if you remember, the shorter the wavelength, then the larger the storage capacity. Using a blue laser also allows the pits and bumps to be smaller, which allows more data to be stored. Blu-ray discs have a single polycarbonate layer, which avoids, is what I was talking about, birefringence. Well, actually, I'll just say this first, because I might as well. I forgot the little title there. Blu-ray discs come with a secure encryption system, which helps prevent piracy and copyright infringement. Birefringence Well, if you're familiar with refraction of light, then what birefringence is the refraction of the laser. So there are two separate beams, and this causes reading errors. So that may happen, and that's a disadvantage of using DVDs with two layers. So, yeah. So let's look at just a summary of all the features of each disc that we looked at, except for DVD RAM, because it's yeah. So CD, I mean, when we say DVD RAM, we kind of mean like, you know, DVD but with concentric tracks. So never mind that. Okay, so CD, laser color red, wavelength 780 nanometers, disc construction, single polycarbonate layer 1.2 millimeters. And track pitch. Now, what do we mean by track pitch? Well, track pitch is pretty much the distance between each track. So, track pitch of CDs is 1.6 micrometers. The micro? Yeah, it's micro. So the DVDs, laser color red, wavelength 650 nanometers, disc construction, double polycarbonate layer. Each layer is 0.6 millimeters, which of course adds up to 1.2 millimeters. And the track pitch is 0.74 micrometer. I keep forgetting it's a micrometer. Oh, I forgot a space between this. Makes me cringe. Blu-ray discs, laser color blue. Oh, it's totally different now. Wavelength is 405 nanometers. Use a single polycarbonate layer of 1.1 millimeters, effectively making it, not really effectively, I don't think, but makes it much thinner layer than these two. And the track pitch is 0.30 micrometers. I wish I didn't put that space there. I mean, I wish I did put the, no, I wish I put the space here, no, hang on. I mean, I wish I put the space here and here in order for everything to make sense. Alright. Anyway, that's pretty much it for optical offline storage systems. And before we go, we need to think about the future. Now, we are noticing that most people nowadays watch Netflix and chill. And, like, they don't really, you know, they don't really use CDs or DVDs anymore unless they're my parents. Now, here's the thing. Like, we use a lot of our smartphones and tablets, laptops, and whatever to store our data. We don't really use CDs and DVDs anymore. Although Blu-rays are still pretty popular, I think. There's, you know, but like CDs and DVDs, not really. And, well, yeah, we need to think about how data will be stored in the future. And it's like, if you remember the floppy disks, really, like, way back, we don't ever see these anymore. So the same thing may happen to CDs, DVDs, and even Blu-ray. And of course, they might be replaced with what we're looking at now. So, like, stored in your devices, stored on hard disk drives, stored in, well, there's the cloud as well. Like, we have Google Drive, Apple Cloud. We have all of this cool stuff. We have the internet. We can store, like, I'm storing my videos on YouTube right now. Like, I'm not storing these on my laptop. I'm storing them on YouTube. Once I'm done recording and uploading, I delete them. No, actually, that's not entirely true. I keep them just in case my channel gets destroyed. I keep them in my hard drive, actually, which is, I don't know if it's solid state or not. Let me check. Actually, I can't be bothered to get it. But anyway, the point is, like, we're seeing a lot of advancements. Like we looked at the advancements of LED monitors to OLED. And that's quite cool, because, like, I mean, we haven't really seen that a lot yet, but we may actually see this in the future. I feel like I'm giving a speech. I actually kind of am giving a speech, but it's off the top of my head, so it's kind of hard to actually think of what to say. But yeah, anyway, that's pretty much it for this video. And yeah, thanks for watching. And yeah, I hope you find this whole futuristic stuff really cool.